Okay, so we will talk about section 5.4 later after we study polynomial and rational function. That section depends on properties of those type of functions. Okay, now let's talk about section 2.1, a new section. In the first chapter, we just studied the basic information about the linear equations, quadratic equations, complex numbers, radical equations, linear inequalities, and inequality involving ops values. And we pick up one section, section 4.5, inequality with quadratic functions. So that's the basic and simple equations and inequalities. And now let's talk about some geometry. Chapter 2 is about the geometry. The first section is distance and midpoint formula. Distance and midpoint formulas. Basically, in the chapter 2, we're going to talk about geometry, like graph. Graph is about the functions y equal to some f of x. You have x, you have y, so we need two number lines, x number lines and y number lines. Okay, so what we do is this way. We put x number line horizontally. We put a y number line vertically. They are both real number lines. And the intersection point is called the origin. Origin, we usually use O to represent. Origin. And we put one is vertically, one is horizontally. They are orthogonal to each other. So this is called the rectangular coordinate system. Rectangular coordinate system, and the horizontal one with x-axis and y-axis. So horizontal is x and the vertical is y, and they are both called coordinate axes. Both called coordinate axis. And when you draw this horizontal axis and vertical axis, you actually determine a plane. The plane determined by x, y axis is called the xy plane. Called xy plane. Okay, this rectangular coordinate system sometimes is also called the Cartesian system. Rectangular or Cartesian, this one. The Cartesian is used to replace the rectangle. Either it's called rectangular coordinate system or Cartesian coordinate system. Okay, and whenever you have a point P, if it's not on the x-axis or y-axis, it's just some random point. What you do is the following. You project this point to the x-axis. Then there's an image. And this point is on the x-axis. It has the coordinate. Because it's on the x-axis, we call it x-coordinate. We label it by x. Project means that this is a right angle. This is a right angle. And you also project this point on the y-axis. And there's a corresponding point, image. And this corresponding image on the y-axis has a y-coordinate. The coordinate in the y-axis. So you have x-coordinate and a y-coordinate. And this pair can uniquely determine the point P. Okay? So any point P in the xy plane can be located by using an ordered coordinate pair, ordered pair x, y of real numbers. So how do you get an ordered pair x and y? We say pair two numbers, ordered because we always mention x coordinate first, y coordinate second. Okay? And x, you see x is here, x, because you do the projection with the orthogonal property. So this side, this is a rectangle. For the rectangle, here x means the sign that the distance is on the right side is positive. Here, if for this case x is positive, then this is also x. This is also x. And y represents this side, and this vertical side is also y. Okay, so that's what the textbook says. Let x denote the signed distance of P from the y-axis. What is the signed distance? First of all, distance means this is distance. You have a point, you have a line. What is distance? You draw the projection. You draw the projection, you measure the segment. Measure this horizontal segment. That is distance. Signed means in this xy plane, if it's on the right side, the distance is defined to be positive. If it's on the left side, the distance is defined to be negative. That's what they call signed distance. Okay? So x here is positive. If we put point P here, then you draw this distance. This x prime is going to be negative because it's on the left hand side. Okay? Here is negative. If I draw the signed distance here y prime, then it is positive because you see this is above x-axis. Above x-axis, y is positive. Below the x-axis, y is negative. On the right side, x is positive. On the left side, x is negative. Okay, so we will summarize it. So first, x is the distance. So now you see here, we already have two explanations. The first explanation was the following. When you have the P, you project the P to the x-axis, then you have a corresponding image. Then the corresponding image has a coordinate in the x-axis. This is x, so you get x. Oh, clearly, this x on the right side is positive, left side is negative. So you have, this is the sign at least is the same. Second explanation, you do not do projection to the x-axis. You directly project it to y. You measure the distance. You measure this distance. And this distance, again, on the right side is positive, left side is negative. So, and also you have the rectangle. Rectangle, this is equal to this. Those two corresponding sides are equal. So those two explanations are equivalent. Okay? And when you know how to find the x and you find the y, let y denote the signed distance of P from the x-axis. From the x-axis. So this is y. And here is also y. The same thing. It's the same. And this pair is called the coordinates of P. X, y is called the coordinates of P. Okay, so let's check the basic property. If we have a point here, then easily we see that it's on the right side, x is positive. It's above x-axis, y is positive. So, and if we have a point here, then it's on the left side, so x is negative. It's above x-axis, y is still positive. Or if it's here, then it's still on the left side, so x is negative. This time it's below the x-axis, y. See, this is origin, this is x, and this is y. Y is negative. And finally, part. Now this moment is on the right side x positive. Below the x-axis, y is negative. So for different regions, you have the classification of the x, the sign of x coordinate and the y coordinate. Okay, and also you see here you have 4 regions. Those 4 regions are called 4 quadrants. Those 4 quadrants, and they are numbered by the following order. This is quadrant 1. Here is a quadrant 2. Here is a quadrant 3. Here is a quadrant 4. Okay, so we number them in a counterclockwise order. You have 4 different quadrants. Over each different quadrant, you have different signs for the x and the y. Right? Okay. So that's the basic stuff. There's many names. You have to just use them, and then eventually you memorize them. Okay. just the names. You have a horizontal axis, vertical y-axis, and for a point you have an xy coordinate. And be careful, the coordinates is ordered. The first one is always x and the second one is always y. So the pair 1, 3 and 3, 1 are different. Okay. Now let's use this to find the distance. Use the distance formula. What is distance formula? Okay, so let's first see a simple example. They say assume we have the 2 points. Let me label 1, 2, 3, 4, 5, 6, 7. Okay, 6. 1, 2, 4, 5, 6. Vertically 1, 2, 3, 4, 5, 6, 7. This is y, this is x. Now we have 2 points given in this xy plane. 1, 3, 1. So first you get the x. X is 1, so it's on this line. 3 is here. Okay, so this is point 1, 3. So x coordinate, you start from x coordinate because y is a positive, so you go up 3 units. And the second point 5, 6. So you get 5, 6. 6 is above x-axis. You just go up. I'll see 6. Stop. So it's a 5, 6. That's a way to determine the point. Yeah. First find x coordinate, then you go either up or down vertically. It depends on the sign of a y coordinate. Okay, so find the distance between the point 1, 3 and 5, 6. How do we find them? Distance is straight segment. This is the straight segment. This is distance. What is d? D, well, in the rectangular coordinate system, we like the horizontal and the vertical stuff. So let's see. We draw the horizontal part, and we get the vertical part. Okay. Okay. Then you can see that you have a right triangle. Right triangle. That's the most important triangle in the geometry. Whenever you have a right triangle, remember that in the right triangle you have the Pythagorean theorem, the Pythagorean theorem. Pythagorean theorem. The Pythagorean theorem says a squared plus b squared is c squared. Okay? Very important. Here we also construct a Pythagorean theorem. And let's count, the d will be the hypotenuse. D is the hypotenuse. Let's try to compute the d. Because you see here, this is horizontal. Horizontal, this is 1. This part is 1. This is 5, so it means this is 5. The distance is 5. So here's 1, here's 5. The difference will be 4. So the horizontal side of the small right triangle is 4. And from the y coordinate, this distance, here 3. 3 means it's a y coordinate 3, so here is the 3. And this is 6, so this is 6, the height is 6, so the difference is a 3. 6 minus 3 is a 3. So for this right triangle, one side of the right angle is 3, the other side of the right angle is 4. So by Pythagorean theorem, the hypotenuse squared is 4 squared plus 3 squared. Okay, this is a Pythagorean theorem. And 4 squared is 16. 3 squared is 9. So d squared is 16 plus 9 is 25. D squared is 25, and we are talking about distance. Distance is positive. So here we say distance, not signed distance. When you have signed distance, you need plus or minus. You need to determine the sign. Is it positive or negative? It depends on the problem. But here we talk about geometry. That's the distance between 2 points. It's always positive. The distance between 2 points is always, non-negative. It could be 0 if they coincide. Okay, so here when you take the square root, you really just take the principal square root. So d is square root 25 is 5. So the distance is equal to 5. Okay, so that's the steps we discussed. And this is an example. From this example, we can introduce our distance formula. Okay, let's see the distance formula. The distance between 2 points P1, x1, y1 and P2, x2, y2 denoted by d P1, P2 is the distance between P1, P2 is, okay, so how do we get this 4? We use 5 minus 1. 5 is the x-coordinate of the second point. 1 is x-coordinate of first point. So we get difference 4, and in the formula we square it. This is a square of the side of right angle. And then we get 3. It's a 6 minus 3. So it's y2 minus y1 squared. So that's a 16 plus 9. And then you take square root. Okay, so that's a distance formula. It's a distance formula. And this distance formula comes from the Pythagorean theorem. It comes from the Pythagorean theorem. And in this part, it doesn't matter which point is the P1, which point is P2, because you have a square. Remember, square, a minus b square is b minus a square. So you can use x1 minus x2 or x2 minus x1 inside the square. It do not change the value. Okay? So you don't worry, how do I label those 2 points? This is P1, P2, or that is P1, P2. Doesn't matter. Okay. Okay, now let's see the computation. Find the distance. D between -4, 5 and 3, 2. Okay, so solution. The distance formula is d is equal to square root. Well, I don't know how long I supposed to draw, so let's wait. Remember, we do the subtraction all the time. X2 minus x1, y2 minus y1. It's always subtraction. So, because those 2 points are already ordered, so we just assume this is P1, this is P2. So it's a x2 minus x1. Very, very important. Then square. It's always subtraction minus a negative number. Plus. Between them is plus. y2 minus y1 square. Okay? Now let's put square root. 3 minus negative 4 is 3 plus 4. 2 minus 5, negative 3. 3 plus 4 is 7. 7 squared is 49. Negative 3 squared is 9. So it's square root of 55. Okay, so here I want to clear something. In the pre-calculus and in the calculus exams, you cannot use calculator. Okay? In exams, you cannot use calculator. So square root of 58 is square root of 58. There is no way to simplify it. So here you cannot write square root 58 as decimal. I say you cannot. You must leave it like this. It doesn't matter what textbook writes. Textbook, they have a calculator. They can do that. They don't do the exam, but you will do the exam. In the exam, your final answer will be square root of 58. Period. If you write any decimal, I will consider you use calculate by yourself, and you will lose points. That's important. And second, based on the problem asked by the student, let me clear. For the square root, if it's not a perfect square, like square root of 4, square root of 25, square root of 36, square root of 49, this one is always irrational. If n is not a perfect square, or if n is not a square of another number, another integer. If n is not square, is not the square. If n is not the square of an integer, then the square root of n is always irrational. Like square root of 58 is irrational. Square root of 2 is irrational. Square root of 3 is irrational. Square root of 99 is also irrational. Okay, square root of 100 is 10, because 100 is 10 squared. Except those perfect square root of n is always irrational. Okay, it is never rational. And for the irrational number, normally we have those square root of n, cube root of n if n is not a cube of an integer, and the pi is irrational. Okay, so that's common sense for us. Okay, now let's see another example. Consider 3 points A is negative 2, 1, and B is 2, 3. In C, 3, 1. We have 3 points. And there's several questions. First question, plot each point. And form the triangle ABC. Okay, we have 4 questions, A, B, C, D. Okay, I leave the space. Let me do the problem first. We have at biggest number 3, most left point negative 2, no negative. Okay. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, negative. So 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, negative 2. This is 0. X, Y. Okay, so first plot each point. Plot, how do we plot? Negative 2, 1. So first define negative 2. The y coordinate is 1. You go up 1 unit. This is A. And B is 2, 3. Fine. 2, 3. This is B. C is a 3, 1. 3, 1. So C. Okay, so that's a way to find this. 3, 1. Here's a 2, 3. This is a negative 2, 1. And form the triangle. Form the triangle. Let's just try to make it straight. It doesn't matter if it's not exactly straight. Okay. Okay, so triangle ABC. And second, find the length of each side of the triangle. Find the length of each side of the triangle. Well, basically you find the distance of AB, AC, and BC. Okay, so the distance AB, remember we have a distance formula. 2 minus negative 2 squared plus 3 minus 1 squared. 2 minus negative 2 is 2 plus 2. 2 plus 2 is 4. 4 squared is 16. 3 minus 1 is 2. 2 squared is 4. Square root of 20. It's irrational. It's irrational, okay? 25 is a perfect square. And the distance AC, okay, AC, 3 minus negative 2 squared plus 1 minus 1 squared. 3 minus negative 2 is 3 plus 2. 3 plus 2 is 5. 5 squared is 25. 1 minus 1 is 0. Okay, this is an integer. And BC, here is BC. 3 minus 2 squared, 1 minus 3 squared. 3 minus 2 is 1. 1 squared is still 1. 1 minus 3 is negative 2. Negative 2 squared is 4. Okay, so that's a distance. So you see here we have distance, distance, and distance. Don't write them as decimal numbers because Remember, in the exam, you cannot use a calculator. C. Verify that the triangle is a right triangle. A right triangle. Oh, let's check it. It looks like this angle is right. If you draw the coordinates relatively correct, it looks like this right triangle. This is a right triangle. It means you have to verify the Pythagorean theorem. The square of one side plus square root of the other side is square root of a hypotenuse. So hypotenuse is AC. And the square of AB, square of BC. Well, you check this is 20, this is 5, 25, this is 25. Okay, it is the equality. By this observation, triangle ABC is a right triangle. Okay, so to verify a triangle as a right triangle, you just check if it satisfies the Pythagorean theorem or not. If it satisfies the Pythagorean theorem, it's a right triangle. If it does not satisfy the Pythagorean theorem, it's not a right triangle. Okay? 4. Find the area of the triangle. Area. This is A, B, C. This is part of C. This is part of B. This is part of A. Let's see part of D. For part of D, let's for the right triangle, you consider one side of the right angle as base, the other side of the right angle as a height. So the area is 1/2 base times height. So for this one, this is a right angle. So BC is a base, AB is a height, or AB is a base, BC is a height. It doesn't matter. So the area is 1/2 the distance AB times the distance BC. Well, AB, where's AB? Here, square root of 20. BC, square root of 5. Is 1/2 square root of 20 times 5 is 1/2 square root of 100. Well, square root of 100 is 10. So the area is 5. The area is 5. Oh, this is page number. It's not the answer. Okay, so area is a 5. When you have a right triangle, you can take the two sides of the right angle, one as a base, the other one as a height. Again, I want to emphasize, don't write square root of 20 or square root of 5 as decimals. You are not allowed to do that in the exam. And also pi is pi. Pi is not 3.14. They are different, totally. Okay, so second, midpoint formula. Midpoint formula. What is a midpoint? Midpoint means here we have, this is a let's say P1, P2, and midpoint M, the distance between P1 and MP2 are the same, and M is on the segment P1, P2. This is a midpoint. And let's try to find the formula for it. And in order to balance P1 and P2, M is the midpoint of P1, P2, then these two small triangles. Right triangles are the same. Okay, so how do we get those small triangles? Assume this is x, y. This is a x2, y2. Here's a x1, y1. Then from the last discussion, we know that this horizontal segment, this is x minus x1. Here is x2 minus x. The vertical, this is a y minus y1. Here is y2 minus y. You always use right minus left, top minus bottom. Okay, so from the identical right triangles, we know that x2 minus x1 is x2 minus x is equal to x minus x1. And y2 minus y is equal to y minus y1. You solve these two equations in terms x1, x2. Basically, let me do it. I move this x1 to the right side, left side, x to the right side. So it's x2 plus x1. Here, x plus x. So it's 2x. 2x is x1 plus x2. So x1 plus x2 over 2 is x. You do the similar computation, you will get y1 plus y2 over 2 is y. So this is a midpoint formula. Okay, this is the midpoint formula. The midpoint M of P1, P2 is x1, x2 over 2, y1 plus y2 over 2. Okay, so let's see the example. The example is just to apply the formula. Let P1 be negative 5, 5, P2 be 3, 1. Then what is the midpoint? Then the midpoint M is x coordinate, sum of x coordinate over 2, and sum of y coordinate over 2. Negative 5 plus 3 is negative 2. Negative 2 over 2 is negative 1. 5 plus 1 is 6. 6 over 2 is 3. Okay, that's it. That is it. So M is negative 1 and 3. Okay, so in this section we learn two formulas. One is distance formula, square root of x1 minus x2 square plus y1 minus y2 square. And we learn this midpoint formula. The midpoint is the average of x coordinate and average of y coordinate. Okay, do your exercise. Ask me questions if you have, and I will try to. I will either send you email back to answer it, or I will discuss in the video. And also in this video, I emphasize you cannot use calculator in the exam, so you are not able to write square root of n as decimals if it's not an integer. Okay, so don't write square root of n as decimals. Okay, we've finished. Thank you. We will start with another videos.